So we're going to calculate the derivative and write the answer in factored form. Okay, so what we have here is a product. And so if I have this product here, I know that I have to take the derivative, not derivative, and then derivative, not derivative. So if I'm going to do dy dx is equal to, well, I'm going to do the derivative first. I'm going to pull the 5 down to x plus 1, subtract 1 from the power. Now, careful, the chain rule kicks in here, so I also have to finish taking the derivative of this, so that means it's going to be times the derivative of the inside is times 2 times the g of x, plus, and then I'm going to do the derivative of the second part for x cubed minus x plus 1 cubed times the derivative of the inside part, which is 3x squared minus 1 times, let's shove this over a little bit, times this part here, which is 2x plus 1 to the power of 5. So that is a lot of stuff. And then it says to leave it in factored form. Well, in order to do so, let's do a quick little review of factoring here. Let us consider if I have 10a to the power 4, b to the power 4, plus 4, let's say a to the 5th, b to the cubed. And if we were going to do this, well, look at it bit by bit. I would first take out a 2. And if I look at the a's, I would end up taking the lower of the two a's. So that would be a to the power 4. And if I look at the b's, I take the lower exponent, because that's what's there, and I would take b cubed. And what's left, I would have 5. This is gone. And now, to get the exponent on b, I know that this value here, when I add them together, I have to get 4. Another way I could do is I could go 4, subtract the 3, will give me a power of 1. And I go through the labor of this because I know when these powers get bigger and crazier and fractional, thinking back to how it's done is really quite helpful. Plus, I pulled out the 2, so there's going to be 2. I pulled out a to the power 5, so again, I think about, okay, it's going to be 5, subtract 4 will give me power 1, and then that is left. So this is fully factored now. The reason why I do this is I'm going to use the same kind of idea here. I have to look for what all my common factors are. And so when I do that, let us consider, I know I have 2x plus 4 to the power 4, and here is 2x plus 1 to the power 5. I also have this is a factor, and this is a factor, and I have 10 and 4. So if I'm going to factor this, I'm going to pull out a 2 first of all, and I'm going to pull out, this is like my a that I had, I'm going to pull out 2x plus 1. If I look at here, here's a 4, here's a 5, can be to the power of 4, the smaller of the two. And if I look here, I also have an x cubed minus x plus 1, and I'm going to, there's a 4, there's a 3, I take the smaller to the power of 3. Now when I do that, what's left on this term here? I'm left with a 5, and, well, this is already taken out, and I'm left with one of these. So x cubed minus x plus 1. Plus, well, I've taken out the 2 from the 4, so there's a 2 left. I've taken out 3 of these, so that's gone. There's no factor for 3x squared minus 1. And I've taken 4 of the 2x plus 1s, so that means there is one of these left inside. So this is messy algebra. So I get 2x plus 1 to the power 4, x cubed minus x plus 1 cubed. And then if I start to simplify this, I get 5x cubed minus 5x plus 5, plus, I'll do the 2 afterwards, I'm going to go 2 times 6x cubed plus a 3x squared minus a 2x minus 1. Okay, keeping it on going here, and I get 2x plus 1 to the power 4, x cubed minus x plus 1 cubed. And I know this here, I'm going to do it above here, I'm going to distribute. I get a 12x cubed plus 6x squared minus 4x minus 2. And so 5x cubed and 12x cubed makes 17x cubes. The next I have x squared, so a plus 6x squared. I have 5x minus, that's minus 9x. And 5 minus 2 will give me plus 3. And so this big ugly mess is our derivative in fully factored form. What I would do, I would actually, now that you've probably taken notes, I would actually hide it and try this problem again. Doing this factored thing is a skill that would be really handy. This is quite a messy one, but the idea of pulling out these common factors that are big and ugly like this will really help out later on.